Hello, we are Yuri and Tobin, and today we will be demonstrating the properties of polymers, specifically polyurethane.
When two mixtures, A and B, are mixed together in equal ratios, they try to form a hard, rigid foam that is the polymer polyurethane. Here we will demonstrate it. First,
We pour in part A.
then pour in the part B, which is very viscous. Now we mix it together. Here, it is beginning to expand in volume and dry.
Unless it's successful explosions, then it might.
Because they can be formed into any shape, polyurethane foams have many uses. Softer, spongier foams are used to make things like seat cushions. Harder, more rigid variants, like this one, are often used for insulation.
We can pour the reactant mixtures into a mold to form any shapes we want. For example, here we are going to use a clay mold to form sea creatures made of polyurethane.
First. A little bit of A. Now, mix them together. As you can see, this type of polyurethane foam is not flexible but rigidly holds its shape. However, we can pour the reactant mixtures into a mold to form any shape we want.
And here's the product after we pour it into the mold. As you can see, it keeps the shape of the mold and has a rigid structure. Polyurethane is any polymer made up of a chain of organic units plus urethane. This is the general formula for urethane, also known as carbamate. Polyurethane is classified as a reaction polymer. This is the general polyurethane reaction. Polyurethane requires polyol, a molecule with 2 or more hydroxyl groups, and a polyisocyanate, a molecule with 2 or more isocyanate functional groups, plus extra additives. The reactants of polyurethane make up a system. Like in our demo, system A is the polyisocyanate, and system B consists of the polyol and other additives. Together, these two systems form polyurethane. These are some characteristics of polyurethane. Polyurethane has excellent resistance to abrasion, oil, solvent, tear, and weather. Because of its rigidity, it has a higher load-bearing capacity than other rubber and can reduce sound. It outlasts other elastic materials and is often used to conduct electricity. Polyurethane is extremely heat resistant and remains flexible from -90 degrees Fahrenheit to about 225 degrees Fahrenheit.
Due to its expanding and flexible characteristics, polyurethane is fitted into a mold to create automobile interior parts, such as seats, headrests, armrests, roof liners, dashboards, and instrument panels.
These two pictures are examples of polyurethane applied to making an automobile seat.
Here are some applications of polyurethane in the interior designing of a house. Polyurethane can be used as an insulator in house construction.
It can also be used as a flooring material.
Polyurethane is often used for water vessels because of its high resistance to solvents, tear, and abrasion. Here are some examples of polyurethane surfboards and inflatable boats. Here are some examples of polyurethane used as a flexible plastic. Because of its flexibility, it has been used to make several tennis overgrips. A thin film of polyurethane is added to polyester to create polyurethane laminate,
which is then used for swimwear because its waterproof and windproof properties.